All right, let's calculate some binomial distributions for lesson 5.9. First thing you have to do is get your calculator into the binomial distribution mode, and that's going to be number 3. And it's binomial because a coin has two choices, heads or tails. We want exactly, so when it says exactly, we're going to do a point distribution, which is number 4, and we're going to use the variable. And they say, what is the number of successes? 2. Out of how many tosses? 10. And what's the probability of success? Well, if it's a head or tail, the probability of success is 0.5. And we calculate that, we get 0.0439. Next one. Number 9 here. A coin is tossed 8 times. What's the probability of that 5 or fewer will be heads? So now when we get our probability distribution, number 3, since it's 5 or fewer, we're going to want to go to a binomial cumulative distribution, and we're going to use the variable. We want the probability of 5 or fewer heads. So 5 out of 8, and each time you have a 50% chance of catching a head, so we get 0.855. Next one. Let's do number 17 here. In a survey of voters, 13 potential voters were asked if they approved of a referendum to fund schools. The decimal portion of voters who approve of the referendum is 0.6. What's the probability that 4 or fewer would approve of the project? Since it doesn't say exactly 4, we're going to do the distribution of cumulative, number 1, binomial cumulative. The choices are yes or no, approve or disapprove, and we want to know that 4 out of 13 approve, and the probability this time is not 0.5 but 0.6, and we get 0.032 would say yes. Out of the 13, only 3 or 4 or fewer would say yes. Number. Let's do the regular die. A regular die is tossed 9 times. What's the probability of rolling a 3 2 or fewer times? So we've got mode. It's a distribution, and it's not point because it's 2 or fewer times. So we have 2 out of 9, and the probability of rolling a die is 1/6, and so the probability of rolling a 3 2 or fewer times is 0.82. Number. Let's do one that has families. Number 33. In families that have 4 children, what's the probability that no more than 2 of the children would be boys? In other words, less than or equal to 2. So this is cumulative again. So we go mode, distribution, number 3. Cumulative is number 1. And it's a list. We want 2 out of 4, and the chances of each one is 50%, and so we would have 0.6875. Number 34. Oh, we want to do different motels one. Motels want to maximize the number of rooms used without angering their customers. The Steve Sleeping In knows that the probability that a customer who reserves a room who actually shows up is 0.922. If they have 201 reservations for the 191 rooms, what's the probability that it will be overbooked? The first thing you have to know is that we are going to figure out the probability that it won't be overbooked. It's cumulative because it's not exactly 191, it's 191 or more. So we've got a distribution and it's cumulative, and we want 191 out of 201, and the probability is 0.922. So we get 0.9557. We need to take 1, subtract 0.9557 to get what's the chances of not being overbooked, and we get 0.0443. A die is tossed 8 times. Oh, let's do a different one. We got the die is the only question left, I believe. A regular die is tossed 13 times. What's the probability of rolling 3, 5, or fewer times? Oh, we already did that one. Let's do this one. A die is tossed 8 times. What's the probability that exactly 3 of the tosses will be 4s? Since it says exactly, we've got a probability distribution, and it's binomial point because it's exactly a certain number. Okay, and what is that number? Exactly 3 out of 8, and the probability is 1/6 for any number, and so we get 0.1042. So this is section 5.9, calculating binomial distributions. Remember, binomial just means there are 2 choices.